The origin of the two satellites of Mars, Deimos and Phobos, is not yet known. Understanding the origin of the Martian moons is the main objective of the Japanese space agency JAXA's MMX mission, which will be launched in September 2024 to the Martian system and will be the first sample return mission of the Phobos satellite. The mission will thus respond to the controversy. Are these moons captured asteroids? Or were they formed by a giant impact on Mars? MMX will provide important information on the formation of planets and on the conditions for the emergence of water on Earth-like planets. The mission will complete a 5-year round trip, with samples returning to Earth from Phobos in July 2029, completing the first round trip to the Red Planet system. The probe will stay for 3 years in orbits around Phobos at different altitudes to characterize Phobos, select sampling sites, observe Mars, and have flybys of Deimos. In addition to the 2 sampling mechanisms and EDIFIX, a rover demonstrator, MMX is equipped with 13 instruments, including the French spectrometer, MIRS. MIRS is an infrared imaging spectrometer composed of 2 boxes. The E-box is equipped with 2 electronics boards, allowing it to control the instrument and to interface it with the MMX probe. The O-box includes the telescope, the spectrometer, the detector, and its proximity electronics board. MIRS is also equipped with a single-axis scanner to control the line of sight of the instrument, a shutter, and a cover to protect the entrance window during landings on Phobos. An internal source allows it to check the good health of the instrument. At each moment, MIRS acquires the image of a line on the target, and for each point of this line, the spectrum of the sunlight reflected on the target is obtained in the near-infrared between 0.9 and 3.6 micrometers. The variations of the signal make it possible to characterize the mineralogy of the observed scene. Thanks to its scanner and the pointing of the satellite, MIRS will be able to map the surface of Phobos with a spatial resolution from 20 meters to a few tens of centimeters for the landing sites. MIRS will contribute to select 2 different sites for sample collection. The probe will descend for several hours on the surface of Phobos to collect at least 10 grams of the regolith. MIRS will make it possible to characterize the temporal variations in the atmosphere of Mars and the composition of the surfaces of Phobos and Deimos. The MIRS instrument, together with the MMX payload and sample analysis, will be able to clarify the origin of the Martian moons and may also be able to elucidate the process of evolution of the environment of Mars.